Okay, so let's look at 7-1, number 3. And again, I like to use rates are when you have two different units. I like to use double number lines for rates. I also kind of like to use ratio tables for those. And so again, I have 10 miles and 12. So again, they want us to come up with maybe 4 different ones and then also try to do some things with decimals or fractions. So let's kind of do that. So again, the easy thing might be to cut this in half and get that in 6 minutes. If I do the half to this, I have to do half to this, 5 miles. I could, if I wanted to go part way in between here, right, I could cut that in half again and get 3 minutes, 2.5 miles. But happen if, well, let's just do that. Let's do that. So 3 minutes, if I cut that in half, this is going to be, let me get rid of this guy. This is problem number 3. This would be 2.5 miles. You could write that as a fraction or decimal. Now, if I wanted to get down to maybe 1 minute, then are you guys okay? I'd have to cut that into thirds to get 1 minute, 2 minute. So that means this 2.5 would also get cut in thirds, because if I cut the bottom in thirds, I cut that in thirds. So 2.5, if I do decimals, that would go in there 8 times, 24, bring down a 1. Bring a 0, that would be 3, which is 9, and notice I'm going to get a repeating 3 there. So that a fraction might be better there instead of repeating decimal, but we could do a repeating decimal, but maybe, fraction might be prettier. So maybe instead I might do, let's see, 2.5 and then divide that by 3. So what is that? 5 halves multiplied by the reciprocal. So this one's 5, 6, and then this would be 10, 6, and this would be 15, 6. So then you can kind of double check that way. Let's see, I'm trying to think. The other thing is you could focus on the, like getting 1 mile. So again, I could redraw this. So you might have focused on that instead. So again, if you have 6 minutes and you have 5 miles, and maybe we had started out with our 10 again. And maybe you decided to focus on 1 mile. So you would 4 cuts make 5 things to measure those out. So we have 1, 2, 3, 4, and you can tell if you mess up because it won't line up nice. And so maybe you want to know what 1 is. So again, if you cut this into, 1, 2, 3, 4, 5 pieces, this 6 has to get divided into 5 pieces, which is a fraction of 6/5, and then this would be 12/5, and this would be 18/5, and this would be 24/5, and this would be what, 30/5. And again, if that doesn't equal 6, you're in trouble. And again, we could also measure out a ways, right? So if I could measure this distance, I could measure that out a ways and get that maybe in 24 minutes. We do, what is that, double 20 miles. Or if I do my 5s, I could go 5, 10, and then I could get my halfway mark, my 15 miles. And then if these go 6, 6, 6, I could do that. So again, you should be able to get fractions, decimals, any increment on there as possible. Now, if you do a ratio table, I don't really like using a table like mixing paint together. But if I do maybe like more of a ratio table, so I know that 10 miles goes with 12 minutes. I could get down to a unit of either of these. So if I divide by 10, I could get 1 mile. I guess I don't need the S. So divide by 10. I could divide this by 10 and get 1.2 minutes. Okay. If I wanted to get to 1 minute, I could divide by 12. So then I could take 10 divided by 12, which again is 5, 6 miles. And then I could scale either one of these up too. So if I wanted to get to say, I don't know, 3 miles, I could times by 3 would be what, 3.6 minutes. Or if I had 1 minute and I wanted to scale it up to say 12 miles, I could multiply by 12 and then multiply this by 12. 12 times 5, 6. Cancel there and get what, 10? What is this, miles? So I don't like doing the traditional table, but I like kind of a ratio table or percent table like we've done in the past, kind of a comparison. and then double number lines. I like those best for rates. All right, let's look at number 8 next. So if you haven't tried number 8, try doing that and we'll look at that video. Okay, here they want us to make 2 tables so that we can kind of do price comparison, and we want to try to get some of the same numbers. So maybe the same number of silly bands or maybe the same price. So we'll do both, and we can scale this whatever. So for example, I might want to do 50 would cost what? Divide by 2, $3, and maybe divide by 2 again, 25 would be what? $1.50. Same thing here. 125, again, you know, dividing that by 2 is not pretty, but dividing it by, let's see, 5 is nice because there's 5 quarters, right? So I know if 5 quarters make $1.25. So if I divide by this by 5, that's 8/5. Now, again, with money, we tend to like decimals, so that's 16/10. So that would be what, $1.60, right? Because it'd have a 6 in the tenths position, so that's $1.60. I could double this maybe and get up to like, you know, $2.50 would be what, $16. I could double again and get to $500 would cost $32, okay? This one I could scale up. I could either multiply this by 5 or I could multiply this one by 10, either way. So if I multiply by 10, I get 500 and I get 30, okay? So I do kind of have the same amount here. I could also get up to 250, all right, you know, by maybe doing 200s with a 50. So like if I wanted to get to 250 or take half of 500, 250 would be what, $15, and 250 would be $16. So already I can see that for 250, this is cheaper. So this is a silly band A is cheaper for the other. The other thing is maybe I want to get the price the same. So let's see, I could divide, let's see, I got 3 here and I have 8 here. So what could I do? I could do 24. If I scaled this up, so I got this down to, well, let's just do 6. If I scale this by 4, I get $24. And if I scale that by 4, I can get 400. And here, if I scale it by 3, I get $24. So kind of common denominator, common multiples, that idea. So scaled it by 3, so this 3 is what, 375. And again, you could do it in one of these tables too. Like you could say, okay, scale it to get that. And then maybe multiply by 10 to get 500 is $30. So, I mean, you could make kind of a long list here, but I'm just putting it in table form. So there's a couple things that stand out to me here. One is either the 50, either one of these, doesn't matter, 50 or 250, or 500, I mean. For 500, it costs $30 here. It costs $32 for 250. You know, it's more expensive. So this one's more expensive. And this one's cheaper. But the other thing I can look is what I can make that judgment based by getting the price the same. Here, I can only buy for $24, I get less of them. Here, for $24, I get more of them, which again also means that this one is cheaper. So again, you know, you can look at the table and you can either look at getting the same number of silly bands and then you can compare the price, or you can get the same price and look how many silly bands you can buy. Either way, you can see that this one's cheaper because you either get more of them for a certain dollar amount, more of them for a certain dollar amount, or you have a cheaper price for the same amount of them. So either way, you can decide. All right, so on that one, you want to do number 6 for me to grade, and then let's look at the next section. Okay, so let's look at number 5. And again, I like, when I'm mixing paint or I'm mixing, like making a punch, I either like to make a chart of batches or I like to do a strip diagram. So let's kind of look at both. All right, 8 says, how much OJ and lemonade should you use to make a juice mixture with 75 cups of OJ? So they're telling me the 75 cups of OJ, and I have 5 things. So if I divide it by 5, each one is worth 15. And so that means every strip is worth 15. All right, so then it says, how much lemonade should you be? You can see it right there. You need 30 cups of lemonade. And then how much total? The nice thing is then you can see the total as well. So I have what, 75 and 30, so what is that, 105? And again, the units don't really matter. I mean, they tell you cups, but it could be pints. It could be anything. So that would be of the drink. Okay, let's look at number B, or letter B. How much orange juice and lemonade should you use to make? Okay, so we want 140 cups total. So the total, and so we have 7 strips. So divide by 7. Each strip is worth 20. All right, and so then it asked me each amount. So OJ would be what? 100 cups of OJ, and then 40 cups of the lemonade this time, because we know the total. All right, the next one is how much OJ and how much lemonade should you make? The juice mixture, you have 15 cups of lemonade. Okay, so now this is worth 15 cups for those 2 strips. So 15, that would be what? 7.5. So that means every strip is worth 7.5 or 7.5. You could do fractions, right? So either way, so you could either take 7, get the 10, bring down the 0 and get your, decimal, or you could do fractions and get 7.5. And so I would need 7.5 times, what do I have? 1, 2, 3, 4, 5 strips. 35, 36, 37, 37.5. And that would be of the OJ, and that would be cups, 37.5 cups of OJ. And then what else do they want? Do they want the total? Yep, and then they want the total. So the total, so 7, 8, 9, 10, 11, 12, 52, and that would be of the punch or whatever you want to call it, okay? And then here on D, it says how much OJ. Okay, you want 10 cups of the juice mixture. Okay, so I have 10 cups total, and I have 7 strips. So I'm going to use a fraction on this. So this is going to be 1, and there's going to be, what, 3/7 left. So the remainder goes over the denominator. So it takes 1 3/7. Oh, did I read that? How much OJ and how much lemonade would you need to make 10 cups of the juice mixture? Okay, so this is the value of each strip, right? So 10 cups total, divide by 5. Okay, so I know the value of each strip, but that's not the question here, right? So I'm going to have to total both of these up. And if you want to leave these improper, that's fine. So if you don't, want 1 and 3, you can just do 10 divided by 7, which is 10/7. I'm going to come down here. So 10/7, I have 2 strips for lemonade, which is 20/7, which goes in there, what, 2 6/7, and that would be cups of the lemonade. And then I have, again, 10/7 is probably easier to work with. Then I have 1, 2, 3, 4, 5 strips of that. And again, if you want to put 1 under there, you can. 50/7, and that is 7 and 1/7, and that would be the cups of the what, OJ, okay? All right, so again, you might end up getting fractions or decimals on those. If you want to do this, you can kind of do it as batches. So one batch is 5 and 2, which adds up to 7. And so this last column, you just kind of total them up. So, but again, you could do all these batches like double and get 10 cups, double, and times 3 times 3 times 3, but it might not be any of your questions. So for example, you might not get any of the, like how many batches here. So here, like I want, 30 cups of lemonade. So I would have to be like, okay, 30, okay, I need how many batches, right? And so then you might be like, oh, I need to go out to 15 batches. Scale this by 15 to get 30 cups of lemonade. Scale this by 15 to get my 75 cups of OJ. And then either scale this by 15 or add those together to get your 105 cups, okay? Kind of the same thing here. You want to get the total of 140, so you might have to keep doing your chart out until you kind of figure it out. So that's where a strip diagram is kind of handy. All right, let's look at the next one. So pause and do the next one, which is what, 9, and then we'll talk about it. Okay, so our number 9, I have my strip diagram 3 to 1. So I have 4 strips. I take 1.5 cups, 3 halves divided by 4 strips, multiply by the reciprocal, I get 3/8 each. So I know I need 3/8 of the frozen, and then 3/8, 3/8, 3/8 is what? 9/8 or 1 1/8 cup of the water, okay? The other thing I could do is I could divide by 4 to get what 1 cup would be. divide by 4, divide by 4, divide by 4. Then I could get a half, so divide by 2, divide by 2, divide by 2, and I could combine these to get my answers. So a fourth and 1/8